At this point, we have seen how to reproduce static data simply by shipping the files or whatever data is required by the program. And we have seen how to record and replay user interaction. However, all of these are actually instances of the same class of input, that is, interaction between the program and its environment. The question is whether it would be possible to record and replay this interaction as a whole. A program interacts with its environment by means of function calls. We use function calls to access data, we use function calls to access user interaction, or generally anything that comes from the environment. So what we could do is to record and replay function calls, and this way we would have a single mechanism to capture all sorts of interaction between the program and its environment. Our plan would be to record every function call with parameters in a log, and then later be able to replay it. Let's first do the recording. We already have seen our tracing functions, where we can access the individual execution frames of a run. And we know that each frame contains the function name, as well as all local variables. When a method gets called, this list of local variables is actually the list of arguments for the function. Here, for instance, I have set up a tracing function, which gets called for every line, as always. It also gets called when a function is called, and in this case, the event variable up here has a value of call. And if this happens, then we print out the name of the current function, and we print out the local variables, which should be the arguments. Let's try out whether this works. What we see here is we have a call to the remove HTML markup function, and s has precisely the value as here in our code. We would now like to turn the function name as well as the argument list into something that can be translated back into code. We want it to look precisely like this. If we turn this into a string that looks exactly like a function call, then we can pass this to the Python eval function, which takes a string and interprets it as code. This is something we will use later for replaying. Here you can see how the string is interpreted and the result is printed. Here's the function that takes care of the printing of the local variables, that is the arguments. Since we don't know the position of the individual parameters in the function, what we use is we print out named arguments instead. That is, we print out name equals value, and this would be separated by commas. Now again, we remove HTML markup with this parameter, and if everything goes well, our tracing function should now print out this very call with the right argument. And this is precisely what happens. You see, we print out remove HTML markup with the parameter s being the string, bold, foo, end of bold. Exactly as over here, except that we do have a name parameter and not a positional parameter. The same mechanism works for tracing arbitrary calls, as long as these are Python functions. So if we call square root of 2, for instance, this would also get traced and reported in our output. As you see here, here's the call to square root, and x has a value of 2. Now let's assume that we do have a variable which actually has stored all these calls. We could do so by recording it right away while the code is executing, or we could also, say, store this in a file and read this back from a file. Your job now is to write a piece of code that evaluates all these calls, first this one, and then the other one, and which prints out the appropriate results for each of these calls in the form function argument equals return value. Over to you.